Alright, I realized that the last video went a little long, but it just seemed more sense to just keep going with that. So this is the second part of it, but we're still going to use our algebra skills to help us transition into our geometry proofs. Often, in fact most of the time, geometry proofs are organized in what we call a two-column proof. Okay? When we do so, on the left side are called the statements. Okay, and you can see that down below here. The left side over here, these are called the statements. On the right side over here, these are called the reasons. Okay, because geometry is very deductive, which means for everything you do, you have to have a reason for it. And you have to be able to state that reason. Now, some of the reasons we can use are the properties that we just went over from algebra. Sometimes they call that the algebraic properties, which is mostly what you're going to use today. You can also use definitions, like definition of midpoint. You can also use the term given, and we'll talk about that here in just a second. And then there's lots of other things that will come into play, and we'll list those as we go. So every proof is going to have a given and a proof. The given is what you're going to start with. It's always going to be step one. The proof will be our last statement down here. For the given, when we write that down, the reason we can write this down is because it was given to us. Pretty simple. Now, what we're going to do then is we're going to say, okay, what did they do to this to get this? So this is like if 4x minus 1 equals 27, then 4x equals 28. So what did they do? They added 1. So my reason here for this statement is addition of 1. Okay. Otherwise, you can also think, and we don't write this usually in our statement, but you can kind of sketch it in here, is how would I solve this thing? Why would I add 1 to both sides? And when I do so, this is my result. Right? 27 plus 1, those cancel. If I was going to solve this, I would divide both sides by 4. The result is this. So what did I do to this to get this? I divided by 4. Done. Okay, that same process is going to be every time. Number 2, we're given this. We want to end with this. Sometimes they're 2 steps, sometimes they're 4. Well, I'm sorry, they're not going to be 2. But sometimes they're 3, 4. They can go up past 20. Okay, it just depends on the problem. So you can see again, this first statement, I'm just going to copy it down. That's given. What did they do to this to get this? Or in other words, how is this different than this? Well, they subtracted 2 from both sides. When I subtract 2 from both sides, this is my result. To go from here to here, I'm actually going to multiply by negative 6. Okay, if I multiply this by negative 6, I get negative 18. If I multiply this by negative 6, they will cancel, and I have A. This is what I wanted to prove or end with. I'm done with that proof. Okay, let's go to number 3. Given, first statement, given. Second statement, what did they do to this to get this? This property here is called distributive property. What did I do to this to get this? Well, to get the negative 18x by itself, I got to get rid of a plus 27, so I'm going to minus or subtract 27. When I subtract 27, this is my result. Now I want to get x by itself, so I'm going to divide both sides by negative 18. And when I divide by negative 18, this is my result. If you have any questions, you're going to have to come up and ask me, okay? All right, let's quick go through these 2 here. All right, so there's nothing written in here, so we get to come up with our own steps. Our first one is always going to be given to us because we need to know what we're going to start with. Now, you don't want to write this down yet because we don't know how many steps it is to get there, but just know that you'll be done when you get to that point. So now we're going to solve this equation. I need to get the 3x by itself, so I'm going to subtract 1 from both sides. And if you want, you can do a little sketching in here if you can't do that stuff in your head. But the only thing I really write down is the result of this. So that would be 3x equals negative 15. What did I do? I subtracted 1. This one, I want to get the x by itself, so I'm going to divide both sides by 3. So x equals negative 5. What did I do? I divided by 3. Done. 2 times x minus 9 equals negative 10. Why? Given. You should never miss that on anything. So we can see right away that we need to do distributive property here to get rid of those parentheses. Here to get this 2x by itself, I'm going to add 18 to both sides. Now you'll notice again, I'm just writing the result of doing that step. Okay, you don't want any of these lines here to show the work for those steps. So what did I do here? I added 18, and now I'm going to get x equals 4 by dividing by 2. All right, so as we went through those, if you're not sure of how we got from one to the other, please ask. All right, bonus, we're going to scratch this one off. How's that? Now, a couple here on the bottom deal with those properties also, just kind of filling in the missing part of the statement. So we're going to use addition property, and we're just going to fill in the rest of the statement. So if a equals b, then a plus 6, there's that addition part, equals b plus 6. We're going to do the same thing to both sides. They were plusing 6, so I have to plus 6. Symmetric property is switching the two around. So if this is LM equals GH, then GH equals LM. There should be a then. Multiplication. What did they multiply? Look at the left side here. This was x, now this is 3x, so they multiplied by 3. So I have to multiply by 3. 6 times 3 is 18. Next one, they wanted to do the substitution. So wherever there's a JK, I can put a 20. Hey, there's a JK. So I'm going to rewrite this to say AB plus, not JK anymore, I'm going to put a 20 there, is going to equal XY. So I'm just completing this statement using the property that they're asking me to. And then our last one, transitive, if R equals Z and Z equals F. So both R and F equal the same thing. Sometimes this would be like the bridge to go from R to F. So then I will know, since they both equal the same thing, then they equal each other. All right, if you have any questions, please let me know.